Welcome everyone to this week's IPLD Sync community meeting. And as every 2 weeks, we go over the stuff that people have worked on, but also discuss any open agenda items people might have, or questions, or project they work on, and so on. So I need to go through the notes, but I don't have any updates. Therefore, it's probably Rod's turn. If you have any updates.
I don't have any major updates either. I was just looking through my activity, and it's all these tiny little things, just maintenance things, getting new releases out, updating dependencies. The only notable thing I think since last time is Go IPLD Prime had a 0.20.0 release, and it's not huge, but it's got a lot of little roll up fixes and a couple of additions, so mostly won't be felt by people, but it's good. It's a good upgrade to do. That's about it for me. Otherwise, I've been doing plenty of stuff around. I'm actually deep in selectors at the moment, doing some really interesting stuff with IPLD selectors, which is exposing some issues, which is good.
Cool. Is it like using the current selector stuff, or is it kind of like thinking about other ways to do selectors?
So it's the current selectors, but really novel versions of them. So right now there's an effort to, if folks listening and not tuned in, this might be interesting or might not be, but there's an effort to replace some of the IPFS.io gateway traffic with, and actually over time, I think all of the traffic through to Saturn, which is the CDN network being built on top of IPFS and Filecoin. So shunting more and more traffic through that, and I'm helping out down at the bottom of it, which is when the requests come through to this huge caching network, how do they get fetched? And so we're fetching data from both Bitswap, the classic IPFS client nodes, but also Filecoin storage providers. So we're doing both at the same time, trying to get the data wherever it's possible. And we're building a retrieval client that does these things and will retrieve a CID and a path into a car. So you can run the thing separately, and you just retrieve and you get a car. So it's a little bit like using IPFS or Kubo and using IPFS DAG export, but it also fetches from SPs, and it doesn't do all the rest of the stuff that Kubo does. It's just purely retrieval. So the interesting challenge at the moment is I'm doing the pathing bit, which is, and there's two separate modes that we're building into it, which is because right now we can fetch a DAG from a CID. You give us a CID, we'll get you all of it. But sometimes people request big CID, big graphs like Wikipedia. You don't want all of Wikipedia usually. So what we're going to do is you get your CID and then a path to some resource. And then the two modes are, we want to give you everything under that path, which is common if you're after a web page on IPFS, then you want all the resources that page links to. And the other mode is shallow, where it's a path to a block, and you just want that block. But the tricky thing is when UnixFS gets involved, because so there's two reasons why UnixFS makes it tricky. First of all, is pathing. So pathing in UnixFS is different to pathing in just pure IPLD. So we're taking the approach like Kubo does, that you want UnixFS pathing if they're UnixFS blocks. So we're doing that. So if it finds UnixFS data, it'll path it according to UnixFS semantics. That's fine. Then when it gets to the end, what does it do? Because UnixFS has a couple of problems. One is files can be sharded across many blocks. So if you want a path to a file, you probably want the whole file, which includes a lot of blocks. So if you do a shallow, let's call it shallow, and you go, so that's what I'm calling anyway, shallow. So you want path and I want a shallow fetch, and I want you to go more than that path. I just want the thing that the path goes to. But if the path just goes to a file, you want the whole file, regardless of whether you said shallow or not. So, and then the other problem is directories. So if you just want to do an LS, UnixFS LS, but then you get to a UnixFS directory that is sharded across many blocks, you need all the blocks to be able to do an LS. So then the challenge is, how do you do this with selectors? So we're converting paths to selectors with these two modes, either full, so get me all the blocks from the root CID down the path, because I want to be able to have a verifiable fetch, so I can verify my CIDs from the one I requested all the way down the path, then the full DAG, or the path all the way down, and then just the resources that make up the final thing. So, so what we do is we turn that into a selector, but then you have to do these things with selectors to do with UnixFS. So you have to invoke this thing that was built into selectors. One of the latest features that was added to selectors in Go, anyway, is this interpret as. So you can tell a selector at each point to interpret this block as an ADL. So what we can do is say, and during the path steps, each step, I want you to interpret this step as UnixFS. So when it goes, /foo, instead of doing it as the sort of the DAG PB block semantics, like going down into the IPLD pathing, it'll say, oh, well, I'm going to load this block and assume it's UnixFS, and then go /foo in the UnixFS path. So that works. But then the other problem is, when you get to the end, you either want to get everything, which is easy. Like, it's easy when you get to a final point, you want to get everything. That's an easy selector. That's the most common selector there is. But when you just want the shallow thing, you've got to do another interpret as. And we have these different modes for UnixFS selectors, where what we've called UnixFS preload, which is when I get to a directory, I want you to get all the blocks of that directory. And so what we do is we say we interpret the final thing as UnixFS. Give me just that thing and no more. So it has to, when it gets to that, it has to either read the whole file and find the blocks for it, or it has to read the whole directory and find the blocks for that, but don't follow the directory links. So this mostly works as selectors, but there's yesterday I was stumbling over a bug in GraphSync that was not doing the interpret as properly, but we're sort of shaking out the bugs of this by doing particularly advanced selectors compared to most of the selectors that are done around the place. So yeah, that's what I'm up to. Interesting work. And yeah, it's just a shame that it's only Go. There's not really mature stuff in the other languages. There's some selector work in JavaScript, but yeah, it's mostly mature in Go.
Yeah, it's cool to hear, because like the basically finally selectors really get used, and it's not only like kind of like a give me only this single block or give me all the DAG, which is the usual selectors we have.
Yeah, that's what I keep on saying is the primary two modes of traversal in IPLD are single block or everything. But there is this gray area in between where things get really subtle, and that's what we're dealing with right now, because we want to be able to fetch efficiently, and for the gateway, you have to make assumptions about what people want and what people are going to want next. That's the other thing, is you can make fairly safe assumptions that people, if somebody shows up for, because we're dealing with often HTTP clients, so they want an index HTML. They're probably going to want all the resources associated with that. So there's all this weird behavior that you got to take into account. So if we can get selectors in there to make some smart decisions up front. The other thing we're doing is we're populating a cache. So that's why what we're doing is, when somebody shows up to the gateway and they say, I want this resource, we'll get them that resource as quick as possible. But at the same time, we're going to populate a large cache of all these nodes make up the Saturn network. We're going to populate the cache with stuff that's likely to be fetched next, but not too much stuff. So that's a bit of a tricky problem, but that's sort of what we're doing. So a an interesting version of that is range requests, because surprisingly, videos are something that people download a lot on IPFS. So you want the gateway to be able to handle video plays, and video does a lot of range requests. So the gateway will get a request for a CID and a path, but then a range of bytes within that. And surprisingly, we can actually use selectors to do that as well. We can do UnixFS, interpret the file as UnixFS, so it's a sharded file across many blocks, but I only want this range of bytes. And you can actually do that with selectors, but it's a tricky one. And then the question is, do we just fetch those bytes for them, those blocks, or do we populate the whole cache with the video that they're looking at, so that when they want the next bit, it's ready to go? So they're the interesting challenges we're dealing with at the moment.
I guess if you need to get the byte offset, you probably need to know the chunking size, right? And you don't really know. I mean, can you probably get the first block and look how big the chunk is, and then expect the chunks to be the same size, the rest?
Kind
of.
Yeah. Yes. So this is unfortunately as well. T size in the DAG-PB does come in handy here, where if you've got a sharded file, you can use T size to figure out where the block ranges are.
Is T like I remember discussions from like years ago about like T size. Is it still populated? Because there were discussions about not populating it, and like
It is, and it ended up getting baked into all the test cases and everything. It's just it's not retired, and it is actually actively used. It's just you're not supposed to take it for granted, but things like range requests, it's kind of useful.
Yeah. So you could basically potentially fake it, and then you end up at a different offset, but you get the wrong thing.
Whose problem is
you're allowed to use it, they're allowed to lie.
Yes, that's right.
Yeah.
and if they lie, okay, you're doing a range request and you get the wrong byte to the file. Whose problem is that ultimately? It's interesting to think about user behavior here, because if I produce bad video content and then somebody tries to do range requests on my video files and it fails, are they going to blame the technology or the person that produced it? That's an interesting question, because I mean, sometimes the answer is either. But just produce good content is the answer.
Cool. Has anyone anything else to discuss or to chat about, or questions?
I was curious if anyone had thought about tagging things in that sort of rel no-follow kind of way. I can imagine you have something that is a chain going back to the beginning of time, and then there's a bunch of transactions hanging off the chain or something. And you might want to have requests that say, oh, go get me the entire chain, but not necessarily go get me everything that's hanging off of every Merkle tree that's hanging off of the chain. Is there any way to distinguish the kinds of links that are in your blocks, to be like, these are the kinds of links to go follow, and these are the kinds of links not to?
Yes, in fact, there's
the sort of go get me the previous field, recurse infinitely.
There is some really interesting integration tests, or maybe they're unit tests, in the GraphSync code base that actually models there's a whole test fixture setup thing that will model a blockchain-like structure. So you've got the backbone of parent links, and then you've got things hanging off them. And there are tests in there that test the ability to just fetch the parent links versus going down. And the way you do this with selectors is just by fields. So you say, navigate into this block, and I want you to explore these fields, either by name or by the index if they're an array. And so typically with a blockchain structure, you will have a field that says this is parent or root or whatever it's called, that links to the previous block. So you can actually, the selector language has the ability to say, only explore further on this named link. And that's the pattern that is used there. So I want you to go back and just get all the parent blocks, like this, that chain, but nothing else that's linked underneath it. So that is one of the primary use cases of selectors that it was designed for. It's not really used much for that, but it is there for people to use. Yeah.
Thank you.
I'd love to get you a link for it, but because I was actually writing some tests using just this the other day. But I was using selectors to do a limit of only go back, because you can do other things like I only want the last 5 blocks. So that's another thing you can do with selectors. I want you to follow parent links, but only 5 deep. So that I was just writing some tests that did that, just to make sure I could control depth in the stuff I was working on.
Or I might have a really obnoxious question. Follow this link back until you get to the thing with this hash. I've already got that one.
With a particular hash?
Yeah, I might want to go back 5 blocks, or I might want to say, well, I know that this hash was one of the blocks in the chain, so follow the chain back until you get to the beginning of the world or some hash that I've got. Which in theory, Bitswap would notice and stop syncing once it got to blocks they already had anyway, because they would all be in the local store.
Yeah, so there's one of the limitations, interesting limitations of selectors, is selectors were written to treat blocks as just a thing that like this transparent thing. So the selectors are written to in this sort of 1,000-foot view of graphs, where graph is just made up of nodes of things, arrays and maps, and selectors are designed to go through those things and then just jump over links transparently. So, which is mostly good, but then you get into these problems of where the block boundaries become critical for your logic. You say, because one thing you can't do with selectors right now, which is really frustrating, is I want to only fetch a DAG that is 3 blocks deep at maximum. You can say I want 3 nodes deep, but one single block itself might have 3 nodes deep, because it might be a map within a map within a map. So you can't currently say with selectors, I want this number of blocks deep, or I want you to follow until you get to this CID, because it's designed to almost be ignorant of blocks and CIDs and all that sort of stuff. So that's a limitation of selectors as they are now. But there is a feature in selectors called stop at, where you can set a stop condition. So keep on going until you find this condition is true. And that might be like this field is something. But this CID is not, I don't think that's one of the stop at conditions. I can imagine it could be, though. You could like go until you find this link that matches this CID. That could be something that could be built into it. But yeah, that's one. Block boundaries are one of the limitations right now. Yeah. But we are at a point where selectors are heavily used, but it's mainly this get me all or get me a path. It's not these really advanced uses. So yeah, the more we can put selectors to advanced use, the more that we can mature them.
Yeah, when I worked on them, like my goal was to be able to traverse through Unix FS kind of with a selector, so that you don't need an ADL, which like basically kind of works, but only if you don't use hands, obviously, because then you're lost, because you don't know upfront how to traverse the hand. So
yeah,
but this was kind of like the goal was to be basically powerful enough to kind of be able to traverse something like Unix FS. This was kind of my idea, but yeah.
Yeah, the named link problem is a problem as well for Unix FS. You have to know where the link is in the list of links, like the index of it, to be able to traverse.
Oh, that's true.
Yeah, that's really annoying about Unix FS. So it's why ADLs become helpful for this. So you can say, I want to traverse this graph, but I want you to see it through this lens while you're traversing it. What I'd really like to do is be able to stack ADLs. I'd like to be able to say, interpret it first as this, and then as this. That's a little bit tricky at the moment. but also we don't have concrete use cases. Although I am tinkering with a use case for that, but not for immediate use.
All right. Any other questions? Else? Yeah. I say thanks everyone for attending. As always, we have an after party for things that people don't want to have be discussed publicly or streamed on YouTube. So feel free to hang out. Yeah, that's it then for the meeting, and we see us again in 2 weeks.